Thank you very much, Lee. All right, good. Welcome, everybody. This is a BoF that started on the back of a presentation I did at the Data Fabric working group at Helsinki. The Data Fabric working group had been working hard to establish interoperability between repositories and actually moving data. But as it progressed, eventually ended up talking more about metadata interoperability than actually moving data, which of course is a very worthwhile topic in of itself, but left the topic of how to actually go about what you do when enormous amounts of terabytes, sometimes even petabytes, kind of get stuck on campus. And me, being a representative of an infrastructure, an e-infrastructure operator, and numerous other e-infrastructure operators that I'm in touch with, felt that this was at least a missed opportunity and potentially a problem as eventually research groups and disciplines move into from the terabyte to the petabyte era. You don't want your data to get stuck. You want to be prepared for this sort of stuff. Also noticing that the research groups that have dealt with this successfully, and we will hear from a few of them, have had to build up considerable tech infrastructure to deal with this. It's not something you do on the back of an envelope under your disk. So what we thought was a good idea, and fortunately the RDA tab agreed, was to have a word with disciplines that feel like it's time to use the excellent metadata annotation that they've already done and the movement towards proper namespace organization, which of course is a topic that sits very well with RDA, to using that metadata to schedule data transfers using preferably underlying infrastructures. Having said that, we've invited 3 research disciplines that have dealt with this either very well or are busy dealing with it, and to talk to you about what they've encountered. And then we've got 3 operators who, from an not-for-profit perspective, so we're not here to fleece you, right? The point is collaborative action. The point is synergies. I'm going to spend a few words telling you what's in place, how they might engage with you, how you might engage with them, to offload those tasks that you don't want to do and to make sure that they deal with your requirements best. Now, we have one big slide pack that I think I'm going to move through, so I'll instruct the speakers to simply tell me to move a slide, and I will do that if that's okay with all of the speakers, and then I will use all of my technological digital prowess to share my screen. I'm about to do this now. Bear with me. Here we go. You should be seeing this. Oh, that button. See, I'm not a Mac user. Everybody seeing this? Good stuff. First up, Stefan, take it away.
Okay, thank you. I'm Stefan Kindermann from the German Climate Computing Center, and I wanted to report about our experiences in the European climate data infrastructure. Next slide, please. Okay, a very short overview of why we have built this infrastructure. So essentially, in the blue box in the middle, you see the European data centers, essentially, which are cooperating to establish and enable data federation. So they all use a common software stack, which is called ESGF, Earth System Grid Federation, which we built about in open source manner the last 10 years. And this infrastructure is essentially, the purpose of this infrastructure is essentially to distribute the data from the modeling center. You see this in the left-hand side in the red button, to our end user community. And so the end user community is the climate modeling community, but also downstream communities like climate impact research and also climate service center, and also other infrastructures, for example, like Copernicus. So this European part of the infrastructure is also closely integrated into the worldwide ESGF-based climate data infrastructure. So nearly half of the nodes are located in Europe. Next slide, please. So the main purpose and objective of this infrastructure is essentially to support the data distribution for internationally coordinated climate model intercomparison projects, so-called CMIPs. So all the modeling centers around the world are working together to distribute their data in a common fashion, common namespace, common metadata vocabularies. And the infrastructure is essentially there to provide common, consistent interfaces to our downstream users. This infrastructure is currently operational. As I said, we are currently distributing CMIP6 data. Around 25 petabytes or 30 petabytes are now available on the infrastructure. And in Europe, thousands of users are currently downloading hundreds of terabytes of data every month. So this is highly in production. Next slide, please. So this is the key slide where I try to summarize the main aspects of our infrastructure fabric. So on the left-hand side, you see the two different data movement routes we essentially support. So one is from smaller data nodes, so-called tier 2 nodes, which the purpose of these nodes is essentially just to get the data from the modeling centers and to make it accessible in the federation. And then there are tier 1 nodes, which more take over federation-wide responsibilities like managing large replica pools in the petabyte range where data is collected and made accessible to the end users. So one route is this tier 2 to tier 1 data movement. This is essentially based on HTTP and Globus and has multiple purposes, like we want to load balance the data access from the end users across the continents, resilience. We want also parts to have long preservation. So in Europe, we have one long-term preservation center. We want to move the data there. So this is the one data movement route, tier 2 to tier 1 nodes. And then we have more the backbone of our data infrastructure, which is the tier 1 to tier 1 data movement. So this is essentially based on highly optimized communication routes between large data centers. So we work together to optimize these routes on the backend side, but also from disk to disk. And also at these large tier 1 centers, all the consistency things are managed. On the right-hand side of this slide, I try to summarize our approach to the problems of data placement, data scheduling, and data integrity. So the data placement essentially is handled in our infrastructure not by end users, but by data managers, essentially allocated to these tier 1 centers. So data users get specify their request in the data management. The data manager is then responsible to do the data placement. The data places are essentially multi-petabyte data pools located in different continents. So we have 3 of them in Europe. And these large data pools are integrated into an overall replication strategy. So we want to have, for example, the core most often used variables located in the US and also in Europe and also in Australia. So just for load balancing. But all the sites are also closely related to site-specific communities. And so they also fulfill their specific requests with respect to data placement. Data scheduling is based on an overall global namespace. So all the data is characterized based on common controlled vocabularies. And so we essentially, in all the tooling we have, we declaratively specify what data should be moved, and this is then translated to the latest version, and then to the location of the data, and then the data is moved. With respect to data integrity, we implemented complete support of PIDs for all of our data. So we have actually PIDs integrated into the metadata of our files. And this is closely so this is also used for managing the versioning and replica relationships between the data. We have also errata service, which allows us to specify why data has been removed and what was the problem with data for which new versions are available and so on. And the key component to satisfy or to support this data integrity is common data publisher component, which is used by all data centers. So this is the key entry point to our data infrastructure. All modifications are made based on this data publisher component. Next slide, please. So a short summary of our experiences. So we moved a lot of data, but the backbone essentially was not the key bottleneck. So we, in the preparation phase of SIMF 6, we had a team working closely together and doing persona monitoring in the backbone and closely coordinating with the national and international network providers. And so the backbone was not the key problem. A lot more work was necessary to optimize the institutional last mile. So from the entry point to the institution to the disk. This is not just a technical thing, but also getting the right people involved and so on. So the next bottleneck we had is we wanted to support high performance transport, but not over at all nodes we were able to support Globus because of different reasons, not always technical. So this is also, so we had always need to support fallback mechanisms and using plain HTTP for cases where Globus didn't work. With respect to the organization, not all of our consistency management issues are completely supported by tooling. So we on the one hand side, we have developed a large community-specific tooling to support the data replication. So from the declarative specification of what we want, to the file list, to the management of the files, downloading, and then making the data available and visible as replica in the federation. So this is a non-sustainable complex tooling we developed. And maintaining the overall integrity of the data is not completely automatized and cannot be. So always people are involved and we need to have a specific organization to organize these people in working groups to get this done. Nevertheless, we were successful in transferring tens of petabytes of climate data. With respect to the future, the current infrastructure is mainly based on POSIX files. So NetCDF files we move around. But all institutions or larger institutions are currently looking into institutional and commercial clouds to host the data and distribute the data. And this is then based on cloud native storage formats like SAR and so on. And how data replication in these multi-cloud environments might look like in the future is something we didn't look into in any detail by now. So this is coming. And I think this is my last slide. Thank you.
Beautiful. Thank you very much. I think we should probably keep questions until the closing of this session, unless there's something absolutely burning with somebody that they're afraid they'll miss when they don't ask it right now. Going once, going twice. Next up, Chris. You ready for this?
Yep.
Excellent. Thank you very much.
Hi, everyone. So my name is Chris Atherton, Research Engagement Officer from Géant. What Stephen was alluding to before, saying that the backbone isn't a problem, that's from a network point of view, that's us. So Guido, Géant, Arne, and others for the research networks across Europe and the rest of the world. Next slide, please. So what I wanted to talk about is this concept of data, or at least the new concept that's coming through from the European Commission, where they're talking about data lakes and being able to have a common pool of data from lots of different disciplines all linked together. So we've got this idea that there's a big body of water, if you take the analogy, and it's how to get or get the data and extract it from these lakes efficiently. And I wanted to talk to you about this in the context of Copernicus, about where we are now, and as you'll probably see, where we've got plenty of work to do in the future for where we're going. So next slide.
You might want to spend 2 or 3 words saying what Copernicus is.
Yes, I'll get on to that. So at the moment, you might have seen this slide before, or at least this picture. If not, it might be coming up more often in the future. So the European Commission wants to have these common data spaces, a hybrid of public and private spaces, or public and private data. And it covers lots of different disciplines, so health and space, climate change, or Green Deal as they call it, and they're basically linked to the different funding pots and funding instruments that are available for that the European Commission use. You've also got EOSC in there, the European Open Science Cloud, and from what we understand, there's this this wish or a desire from the Commission in order to try and create a way to link all of these data spaces together. Now, I don't see this as one huge platform to rule them all. The only way that this will work is if it's operated in a federated way. So each of the different research disciplines run their own data pool and allow that data pool to interoperate with other data pools. So this is why it's more, rather than a sea or a lake, a collection of ponds that are all linked together with like a common architecture. But this is going to be a big challenge, and it's going to take some time to do. And I think some of the work that's been done, which Stephen mentioned about, or Stefan, sorry, about namespaces or common namespaces between data centers in order to try and link them together, may well be an area worth exploring to try and achieve this vision. So next slide, please. Everyone kind of, well, when I've been speaking to people who don't talk about the underlying infrastructure, they say, oh, let's just put it on the cloud, it'll all be fine. But in reality, the cloud is just someone else's computer. And what that means now is, in the context of Copernicus, which is the European Commission's, or the Europe's satellite system for Earth observation, we've got a cloud infrastructure that supports the distribution of that data right now. But it doesn't integrate with other cloud systems. So if we go on to the next slide, and I'm going through this really quick as well because I'm just conscious of the time. So from a user perspective, if you want to receive some Copernicus data from Sentinel-1 or 2, and they're the satellites or the satellite series, you go onto this website, which is the Copernicus Open Access Hub. You get a nice web interface. You type in what type of data you want from Copernicus, select the area that you want the data from, and you're given a list of all of the different images over that particular region for an allotted period of time. But how that actually works from a distribution point of view is we've got a data center that's based in Frankfurt. It's a huge collection of machines, and from that data center, there's a 100 gig link to the German Research and Education Network. And then they have multiple hundreds of gig connections to Géant, and Géant then connects out to the rest of the world to send the data to R&E users. So anyone that's connected to a university and downloads the data through the university or an academic institution of any kind would likely go via your National Research and Education Network. So the data will come through us. For those that access it from home, you'll receive your data from the commodity internet. So that's the bit at the top there with the little cloud that says non-R&E and then multiple 100 gig. So Géant actually pays for this link to be set up, or at least the European Commission and ESA pay Géant to set this up. One of the challenges that we've seen is that the actual amount of data that can come through to users at the end is quite small because it's scaled for generic internet use and not the high capacity bandwidth that you can get through research networks or to utilize the 100 gig fully. And the buffer size on the servers, we've seen a smaller for the demand that needs to be supplied. So when some of our Greek colleagues helped out, they were able to tune the buffer sizes to the right scale, and that way the data could actually reach people at home or in big data centers elsewhere in the world more quickly. And this was just to kind of reinforce this idea that it's not just as simple as clicking a button and it'll download to you. There are things that need to be done in the background in order to try and move this data from one place to another. At the moment, this 100 gig link is only putting around 35 gig a second through. It's possible that we could get her up a lot higher if it was if the firewall was different, which is another subject entirely. But this data doesn't actually integrate with other systems unless you use an API. And what some people have done is they've created batch scripts and dummy user accounts to try and retrieve more data by having concurrent downloads going. So when you try and download this data from the Copernicus Open Access Hub site, you're only allowed 2 concurrent downloads at a time. And one of the sneaky things that people have been doing is setting up multiple users to download 2 per user. So I think one organization in Australia had about 100 different user accounts that they created so that they could try and get the data more quickly across the backbone. But the really, I think, interesting bit for this in the context of the data movement in general is that the backbone network itself isn't really the problem. It's always the endpoints, but there are things that could be done on the data center side to tune things so that you can make best use out of the infrastructure that's there and available. And when it comes to the likes of the data lakes, we probably need to think more in terms of platforms that sit on top of the data that can move around or move to the data to extract it in a federated way, rather than the data necessarily coming to the platforms all the time. But anyway, that's a bit of an abstract concept, and yeah, we'll probably talk more about that later. So thanks, Guido.
Excellent, thank you very much. I feel bad for berating you for your enthusiasm, but 5 minutes, people, please. Alrighty. Next up is Justin, if you're ready.
Right, 5 minutes.
Excellent.
I'll try. Okay, so my name's Justin Clark Casey. I'm a EOS program manager at EBI. I've only really started doing this stuff recently, kind of been peripherally involved. So anything I say that's complete howler or completely inaccurate is completely my fault, and I take full responsibility for it. Next slide, please. Okay, so very briefly, what is Elixir? So Elixir, for anybody who doesn't know, is a European bioinformatics research infrastructure. So it's one of these kind of virtual organization. I don't know if that's the right word, but it's kind of composed by a bunch of nodes, which are mainly country-based, and then a hub and actually collaboration. So one recently, Tex has been hidden, but with Australia Biocommons, which is going to be very promising, I'm sure. Yeah, so the nodes are mainly countries plus me, plus us at the EBI. Often situated in kind of computing organizations at a hub, which kind of plays more of a coordination role. So I think this is kind of like say that this isn't one big project like I think the other ones have been talked about. This is kind of more a loose confederation of people who have common interests in terms of data transfer, and we try and get things together, but really there's a very big array of activities. So EBI, for instance, tends to concentrate on archiving and providing access to already processed data, but other nodes will be doing much more of the kind of raw data transfer and manipulation there. So next slide, please. Okay, so just a couple of challenges. I'm not really at the super heavy technical detail, but more at the kind of like the interface to the user. So, you know, EBI is something I can talk about. I'm kind of new, so I can't talk very well about the rest of Elixir, but EBI, for instance, does serve a lot of data, and we have these different ways of getting data. Aspera is one that continues to play a role. So in this graph, on the left-hand side, you have terabytes, and on the right-hand side, month by month. So you see it's going up by month. The current doubling is approximately 1 year. So yeah, we're using Aspera. We're starting to use Globus more and more. You can see from the green line there. And FTP is still proving popular because it's in kind of like pipelines that already exist, and it's kind of something people are familiar with who are using this. So that's still there. But really, I mean, raw transfer out, I don't think is our. Of course, it's getting bigger and bigger. But is it really our major challenge? It's something we've got a handle on. So there are other things coming up. Next slide, please. So first kind of challenge is when the data can move. And it's when does that data move? I mean, we all know the issues with one-off file transfers. It's kind of like a manual thing. It's ahead of time from remote locations and different kind of directory structures. So we know this is not working well. It's inefficient and cumbersome. And so there's a couple of responses to this. I mean, EBI, as I think was in the text, was working on its own dataset distribution service, a bit like the ones we've heard previously. But although this has been happening for a number of years, it's actually been getting no real pickup by users. So I've recently decided to kill it. I mean, the reasons why it hasn't got pickup are the kind of thing which is quite, I'm kind of finding as we go along, it's quite difficult to actually get at some of these reasons. But really, there was no enthusiasm. And I think one of the things was it's a bespoke system, which is always going to be difficult to use and maintain. And really, it wasn't getting any play. So what we're really looking at now is One Data as this solution. It seems becoming increasingly popular out there. The EGI have just recently based their data hub on it, as I'm sure Andrea is very familiar with. And so this is kind of interesting because instead of trying to push these reference data sets ahead of time and trying to determine, well, what is even a reference data set, it's more kind of a pull system where these things can be pulled and cached. And of course, you lead to kind of namespace issues there, which really haven't been tackled. But it's kind of like a different kind of solution because we don't need to decide what people are interested in up front. And it kind of has these capabilities also for doing kind of chunk transfer, which would be interesting. But the other kind of response is to have RDSDS now support something called DRS, which is a kind of Global Alliance for Genomics and Health API. So that's an attempt to standardize kind of APIs for data location discovery, but being able to know how you're going to be able to fetch data. So instead of everybody having their own kind of way of doing this, instead there's some consistent API for getting that, and that's something that comes in your workflow. So that's one challenge. Next slide, please. But also another challenge, which actually might not be relevant to us here, because it's the challenge when you can't actually move data. So in many countries, kind of human omics data, genomics data, by law can't leave its home country and often doesn't leave its home institution. So instead of a data transfer issue, we almost have like, how do you bring compute to the data issue? So there's a couple of responses to this. One thing going through at the moment, the major one really is federated workflow. So again, there's a GA4GH API, task execution service, and a security one, Passports, which tries to enable you to go and run your container on the compute where the data is. So kind of a bit similar to AWS Batch to get around this fact that the data can't travel out. And there's other alternatives, like there's a thing called the Pulsar network in Galaxy, for example, which is nodes of the Galaxy, which is workflow system running on different locations. But that's more oriented at the moment towards cloud bursting, but that could be another thing that comes into play. And then among the first users of this are projects such as Sinica, which is something to perform federated cohort analysis on data, which are starting to look at these things and actually try and put use cases on them. But there's a couple of issues, one which always comes up to me, which I'm not really sure how serious of an issue this is like, can you even situate compute next to the data? I'm not sure how that always works out. And finally, another kind of more political issue is, how is this actually funded? If everybody's providing a little bit of computation, then everybody needs a little bit of money, let's say, or honey. But this is hard to actually fund, because these things are usually set up in advance between known sets of users. But if we ask, for example, has this ambition to serve a long tail of research, then how do you actually get people paid for this? This is going to be a considerable issue, because the kind of mechanisms simply aren't set up for this. And so that's it. That's my slides.
Thank you very much. Allow me to say one thing about this. What I find funny is that, and you touched on it, is that it isn't actually all that easy to move compute next to the data. It is often cited as the next paradigm, and that is how it shall be. But if you've noticed, the past 3 presentations did not mention it. It is not that easy. So perhaps perhaps we will all coalesce on that in the future. But for the midterm, it looks like we will simply have to be able to deal with data movement. And you can't simply wish for the silver bullet of moving the compute to the data to happen. It doesn't seem to be, I'm not saying I don't like it. I'd love for that to happen. It just doesn't seem to be at hand. So as a general caveat. All right.
It's got a lot of challenges, but I think we are forced to do it. We don't have an alternative. So this might be
you're forced to work on it, and and it would be a beneficial future if it came to be. But for the moment, it simply seems to be that when people deal with the task at hand, what they end up doing, simply for reasons of policy, availability, what have you, they end up moving the data.
Right.
So as a caveat, right? Unless somebody wants to
if
counter
you have an
this
alternative,
argument.
there might be better ones. Yes. Yeah.
Absolutely. Yes. I'm not saying it shouldn't happen, just that, si vis pacem. That moves us to the section where the operators will tell us a few things about what the present capabilities are and what technology solutions, engine rooms, if you will, we might be able to consolidate on. So see this, I guess, as a takeaway menu. First one up is EGI. Andrea, are you ready?
Yes.
Fabulous, please.
Excellent. So I'm Andrea Manzi from EGI Foundation. I will, if we go to the next slide, we start and describe a little bit what is EGI. So it's a federation. EGI Federation is an international infrastructure and provides advanced computing and analytics for research and innovation. We started like 2010 supporting WCGI energy physics computer grid, and now it's become a multidisciplinary and multi-technological infrastructure supporting a lot of different communities and virtual organization. The next slide is describing a little bit what are the participants of the GI. So there are like 23 countries plus international organization like CERN and also INES that was presented before, and EMSO and ASCAT that has been added, like joined the federation like maybe last week. And everything is coordinated by the GI Foundation, which is in Amsterdam. And maybe this a bit moved, but it's Amsterdam, not in UK. And if you go to the next slide, I see that describe a little bit what are so basically there's a federation of cloud providers in which is European. So we have 25 cloud providers plus lots of HTC providers that are coming from, thanks also to the partnership with the International Infrastructure Initiative, basically, all over the globe. And so coming to the topic of today, which is, data transfer. So the next slides, I describe, why the transfer in AGI. Basically, the main use cases are distributed experiments raw data for resiliency and archival in different size. For this, we use data transfer for distributed computing and data analysis in the infrastructure, but because, of course, as I said before, data locality is fundamental. And to perform data placement that is orchestrated by data management system, mostly driven by the workflow management. and also perform asynchronous movement of computational outputs and management of also of cold storage and archival. The next slide describe what we usually what are the services that we provide for the transfer. For instance, the first one is the FTS, which has been developed at CERN. It's a low-level data movement service which provides reliability, integrity, flexibility, intelligence in data movement, and basically it has implements multi-protocol support, compatibility with different storage types that are available on the infrastructure, which are quite heterogeneous, but this is decided by the sites directly. Checksum under tries, parallel transfer scheduling optimization, and support for priority activities for transfer classification. And this is already integrated with the various data management systems that are, some of them, operated directly by the experiments. Next slide, please. And then we have what we are doing now is, and what will be the next service operated by the GI is Rusio. Rusio is software for developed also at CERN in the context of the Atlas experiment, and is currently managing more than 500 petabytes of data for over 72 sites. This service is under integration of many communities, also outside the energy and physics, and use an FTS underneath for the data movement. And basically, this is going to be operated by STFC RAL, one of the provider of the infrastructure. The next project will start in 2021. Will be operated in order to be a catch-all instance, so multi-VO interface also with the rack for the workflow management. And one example of, if you go to the next slide, I have an example of communities that they're moving or they plan to move to Russia, which is the Belt 2 experiment, which you see that growing. They are going to grow during the next 4 years. For the storage occupation and estimation of the raw data and Monte Carlo production analysis, and they're going to move. So it is an experiment that is in Japan. So the detector is in Japan. They're going to initially moving data only to BNL in US, but next year they're going to moving also data in some site in Europe, so duplicating the second copy of the raw data in Europe. And in order to implement this, instead of implementing part of their distributed data management system, which is based on Dirac, they have basically decided to move to Rusio, and some of their implementation and some of their activities will be reused to enable Rusio also for other communities. Now, there's another service, if you go to the next slide, that's also been mentioned before by Justin, is the GI Data Hub that is based on the One Data technologies. And this service, basically, this software allows transparent data access on their common space, regardless of the location of the data, which can be also accessed via open access or restricted by virtual organization. And basically, mainly it's a service that is in beta phase, so it's piloting by different communities now, and it exposes existing datasets and implements data caching at computing facilities, and will possibly be integrated also with FTS. And one example that I mentioned in the next slide is the Photon and Neutron community in Panos. It is a project where NGI is also a member. So basically, what they're basically it's a series of different research infrastructure in the Photon and Neutron domain, which basically they have local architecture and the infrastructure for the analysis, and they would like to scale up with using, for instance, AGI cloud HTC or cloud or HTC, and the hub will help them moving data caching to the close to the computer facilities that are provided by AGI. This is something that is under piloting now. So as and then just to conclude, I think that it was quite fast, but we are late. The last slide, sorry, if you go to the last slide. So there are many communities that rely on distributed computing and storage in AGI. We are, using and promoting low-level data movement services like FDS in order to avoid overloading storage network in some cases. And we are going to provide also this Russia as a policy-driven data placement services, which is going to be a core component in GI starting from next year. And of course, we would like to have existing and new communities converging on the SIG technologies and tools like the one that we are providing, but also other infrastructure we know that we are providing. Thank you. This was my last slide.
Thank you very much. And a remark / a question to you and to a few of the previous speakers. There's an observation here that even established research communities who have dealt with data movement at scale before are moving away from their bespoke stacks and are consolidating on 2 or 3, right? Roughly. What I've heard so far is One Data, Globus, Ruscio, essentially.
Yes, this is.
And that's an observation, not just from us, from operators. I can corroborate that that's what I'm seeing. From research groups, we've just had presentations on this. And the point is that these are research groups that have dealt with petabytes before and have career paths for coders, and they're still moving away from bespoke solutions. That is the writing on the wall for me. That makes it so interesting and so pertinent that we deal with this now and try and at least make ourselves available for those people who want to also consolidate on these stacks. What you didn't mention, Andrea, is that even SKA, the Square Kilometer Array, are investigating Ruscio as a shared infrastructure for their data, which is not a small experiment either, right?
Yes.
So it is likely, if you were to bet $10 on something, bet on the fact that these consolidated stacks are going to be around for the next couple of years. And so if you as an experiment, any of the audience right here, are able to consolidate on these, if you find that you have the metadata and the ability to schedule your workflow arrangements around these sorts of stacks, around the assumption that these stacks will be available, you're betting on a strong horse, I think.
I think it's interesting in the context of EOSC as well, wanting to establish these kinds of common services. And if everybody, if there's a movement towards taking these up, then that starts to push those forward as perhaps the acceptable. I know there's always talk of federation, right? And it's all very great, but sometimes it is easier to all be using pretty much the same thing at the risk of having a monoculture.
Well, there's at least 3 solutions that we've heard about, and relatively large communities betting on either of the 3. So it won't be a monoculture, but it certainly won't. It looks like it won't be a zoo anymore in a couple of years' time, right? With 15,000 different bespoke solutions based on a spaghetti ball of PHP code. That's just gone out of the window.
And things like EOSC, I think, are going to push towards that as well. From
that's the slides that Chris just presented on the fact that the assumption from the EC is that those people who are able to arrange themselves in terms of data pools, data puddles, like the analogy, you'll make yourself a palatable funding target, right? That is a really interesting observation, which is a great point to switch to a US perspective. You ready, Frank?
Yep. So I don't have slides on what is OSG. You can think of OSG as the US sister of EGI if you want. And I will talk about 3 standard use cases and then raise an issue for the future. And I'm thinking, the way that I'm thinking about this is that OSG needs to support a very large dynamic range of communities, all the way from the very largest petabyte to exabyte scale to the much more modest terabyte scale data volumes. And the 3 use cases that I am going to describe delineate less the technologies and more the types of use of data. And so off we go. Next slide, please. I want to start by ways of using data only to move it around, meaning communities is in our sphere of influence, say, use Ruscio for data catalog and data placement policies, and then FDS to manage transfers. as long as all that's required primarily is to move large volumes around in a convenient and automated fashion. And so example here is the Xeno-110 experiment that years ago had this challenge of having an instrument in Gran Sasso, Italy, a tape archive in Sweden, discharge in 7 locations across Holland, Italy, Israel, France, and the USA, and compute sites on both EGI and OSG, and an NSF HPC allocation. And they had to somehow combine all of this and move data around at the petabyte scale between all of these. And they then were advised to build something around Rusho. And I believe they were the first non-Atlas community used Rusho. That's sort of, in some ways, the Rusho expansion across the globe into new communities started here at some level, I think. I'm not willing to bet that, but I think that's sort of history. Next slide. A very different way of use of data is data entirely as part of workflow, meaning the only purpose and rationale for moving data around at all is workflow related. The most obvious and classic case for this is output. So you're doing some simulations across a distributed infrastructure, whether that is EGI, OSG, or something else, doesn't really matter. And you have to aggregate your output somewhere because you've produced it distributed. And GlueX is an example of this. It's an experiment at Jefferson Lab that produces simulations OSG. The pie chart here is the hours across locations, clusters basically. It's 7 million in total. And I think the highest one is Syracuse. The second one was Glasgow. The third one I've forgotten. And somewhere in here, third, fourth is somewhere in Italy. And then it gets smaller and smaller. So fundamentally, the experiment has a mix of opportunistic use in various places, plus contributions via some sort of MOU to the experiment, and they produce across all of this, and the output has to move back to where to a central location. And they use HECondo file transfer for this in order to convince them that this is a viable option. We validated it to scales up to about 50 terabyte per day, which far exceeds what they actually do in practice. So there was a validation campaign to just verify that the technology can sustain 50 terabytes per day of output handling. Next slide, please. Then the third option, third type of use is what I sometimes like to call the YouTube for open science. If you think about for a second, what is YouTube? YouTube allows anybody to add data in. It allows anybody to take data out, and it makes that data appear equally accessible no matter where you are in the world. And that's basically what we're trying to accomplish with this here. So I call it a data federation. It has 6 origins at this point, meaning that we can integrate your storage system via a relatively modest API that we can even deploy on your hardware via mechanisms like Kubernetes. And then your data automatically becomes accessible according to your decisions into a namespace that you decide who has access to. And then it's our job to make sure that no matter where you compute, it is equally well accessible. And for that latter thing, we deploy a distribution of 18 caches right now across 3 continents. And you sort of see here the globe. And some of these caches are actually in the network backbone, meaning at POP's point of presence of Internet 2 and a regional network, the Great Plains network. Others are at endpoints. And the idea here is that users, scientists, researchers don't have to worry about where the data is. They just submit their jobs. Magic happens. Once you arrive locally at wherever you execute, the infrastructure figures out where the closest cache is, and you access the closest cache automatically, and things flow. And I've shown you here the kind of a few examples of the top 7 most popular data areas. We monitor how much data is accessed from which namespace piece. And I've then calculated this into reread multipliers. The message here is, if your data has a very large reuse, it doesn't make sense to move it around every single time when you use it. And so you're much better off having a global caching infrastructure if you're globally distributed. And that's what this does. Next slide. Then there is, my last point is, there's a big change coming, and that is the retirement of Globus. As most of you probably know, Globus was, support for Globus was discontinued in 2017, I believe, if I remember correctly, 2017, 18, thereabouts. And so as a result, EGI and OSG took over maintenance of Globus in the intervening years, but that can only last for so long. And so there is a planned retirement of Globus coming up in the next few years. And that planned retirement is allows for or implies an change in auth-Z paradigm and a change in protocol. We're replacing GraphDP with a third-party copy HTTPS based on WebDAV, and we're replacing an authorization paradigm that is fundamentally based on person, meaning I am allowed to do something and my credential flows down to wherever it has to be. And then you have to all of the problems with issues of my identity being compromised, et cetera, to a model where the paradigm is based on activity, meaning you get a token that is allowed to do X and only X, and X is exactly what this token is supposed to do and what that token ultimately does in the point where it arrives at and where it is used. For example, a token could identify you're allowed to access this part of data in this namespace at this location and nothing else. And voila, then the token travels, and when it gets compromised, or if it were to get compromised, it wouldn't matter that much. Next slide. And here's the current schedule, and check marks imply that this has been accomplished, meaning goals have been met. I think the easy ones have been met, meaning the ones where you don't have to do global coordination have been met because they're technology issues that we can deal with in the US by ourselves. The hard part comes in January 2022, or let's say in the interim between January 2021 and January 2022, when the world has to change, because if you want to move data from EGI to OSG or OSG to EGI, supported infrastructure, both of them have to speak the same language. You can't expect that on one end data comes out of HTTPS and on the other end it gets received by GraphDP, that sort of thing. And so there is a big change happening on this time frame. And personally, I expect that this deadline of January 22 is probably going to slip because of this kind of global coordination of moving the world forwards. And last slide, I think. Summary and conclusion. OSG's objective is to advance open science through distributed high throughput computing. Guido mentioned earlier the question of, do you move the data? Do you move the jobs? What you've seen in my presentation is that I think that where the world is heading is that this question becomes irrelevant because you actually will do some of both. In particular, if you think about the data federation and caches, most of the time, both happens. Compute moves and data moves, and most of the time you compute in a third place where then magically data has to appear and be accessible. And that's sort of, if you think about it, that's really what happens in YouTube when you consume a video in Starbucks around the corner. You don't know where that YouTube video is actually located or originates. You have no clue how it gets to your laptop and gets viewed by your software. And that's sort of where I think we would want to be eventually, that data access is mediated via networks with caches in the network infrastructure and at endpoints, and that the compute providers guarantee that the data access capabilities are in place such that the scientists and researchers no longer have to sweat this. And this is all I had to say. Thank you very much.
Thank you very much. That's a very good point on the ultimate, well, the longer term future being one where data and compute are able to move. The point is that that is something you tell an end user. You know, in the end, that's it. That is how you will do your science. I think it's criminally negligent to tell research disciplines, just wait for the computer to be mobile. You don't have to do anything.
Yeah, we're going to adjust to this over time. And yeah, the purpose of having distinguishing three paradigms of use of data was to, when everything is said and done, you want to choose the simplest solution for what you want to get done, right? Yeah. And a simple Rusho may not be the best solution if you're a small outfit that all it wants to do is reuse a small amount of data. And you might be better off in some cases doing something else because your needs are different. And I was trying to show you three ways of thinking about this and then picking an appropriate tool. That's basically the message.
But as a research discipline, you have to be ready to do both, right? Or at least you position yourself best for the future if you are able to structure your data or your metadata such that it can steer the decision-making processes both in a compute mobility and a data mobility platform. One remark for the avoidance of doubt, you said that Globus entirely was going to be retired. What happened, I'm just saying this for the benefit of the audience, Globus used to be a fully open source, community-driven solution. They have closed sourced themselves and are now a commercially run operation, still out of the R&E community, but they are for profit and for a fee, meaning that some communities have decided to get the licenses and still roll it out, and some communities have decided that it is better for them to consolidate on a stack under their own control, which, by the way, more or less explains the rift between Rusho on the one hand, driven still by CERN, and communities who are less invested in running their own digital infrastructure, moving to the hosted Globus solution.
Yeah, and the tricky bit in this is that right now, these two things are interoperable.
Yeah, meaning because they're both based on GridFGP.
The same stack.
Yeah.
And the question is, when does this interoperability stop? And then things get interesting and difficult because you might have a university may have to support multiple stacks simply because they want to share data with the part of one community that uses commercial tool and another community that uses an open tool. Yeah, and that's going to get very, very messy very quickly.
Well, we're going to have to ascertain, and the more this is actually a reason why a BoF like this exists. The more we're able to collectivize our demands and requirements, the better the articulation we can have over certainly at commercial providers. Good point by Justin. I don't know whether they are for profit necessarily. They are a commercial operation, and they.
Yes, you go to their webpage and they say a non-profit service up above. So I don't know what that covers, but that's what they're saying. They are non-profit.
Yeah, right. And in any case, they are for fee nowadays. So that
I agree.
No, they have subscription. They have subscription based. So basically, there are some of the functionality are for free, and some others you have to.
But you can still, formally speaking, you can still be not for profit and still charge a fee, right?
Yeah.
Anyway, I don't represent Globus. I'm merely in part a user of their infrastructure.
But I will say I share the same concern about this no longer being an open system. Anyway, so I'll let you get on. Yes, I know time is short.
But these are, if this BoF turns into a working group, this is definitely one of the items, policy control, governance, and articulation of demands towards commercial operators and large-scale infrastructures. that I think is worthy of a dot point. Over to Chris again, but this time in the role as a representative of an infrastructure provider.
Hi. Normally I have a beard, so this is my alternative ego with a mustache. Just to give you a brief recap on Giant and who we are. We're a membership of organization of over 40 different national research and education networks in Europe. We support about 10,000 institutions and 50 million academic users. We're like the underlying infrastructure which pretty much everyone is using. We connect up all the EGI nodes, we connect them to OSG, CERN, so if it's research data, passes more or less normally across our network. As I say, we've got a number of partners around Europe. So we're not just the European Union, we're larger than that. We cover the whole of the continent of Europe, going all the way from Iceland through our partners in Nordinet and in the northern parts of Europe, all the way to the south, to Turkey, Israel as well, and Azerbaijan all the way over to the east. And then we also help connect down to the likes of other regions in the world, but I'll come on to that in a second. Because we're a membership organization, we're involved in lots of different projects. The main one is the Giant project, because that's where we get the name from. I think originally it was Gigabit Ethernet Network and Technology or something along those lines, but now it's we probably use the French term for Giant because it's pretty big. We also help establish research networks in other parts of the world as well. So we helped with connecting parts of Africa, Latin America, and Asia, and we helped to set up similar organizations to Giant, so a regional research and education network in Latin America and 3 parts of Africa, and we do that through Africa Connect and other projects. So this is our famous squiggle, which is really confusing to look at, and it's the spaghetti map. But basically, we connect all of Europe, and there's lots of different capacities. We support a large amount of data at the moment. I think it was something like a terabit of data a second it hit not too long ago, which from like an ISP's perspective, it's not huge, but it's still pretty significant. We're in the process of upgrading the network. So we're going to connect all the countries up to have at least 100 gig each, and that way it will support exascale capacity in the future to support the likes of the high performance computing, European Open Science Cloud, and everything else from all of the different domain specific major projects that are going on, not just in Europe, but globally. And in terms of the global reach that we've got, as I said before, we connect up to all of the different parts of the world. So all the way down to Australia through the services that Guido and Arnett provide. We go across to America through not just Giant's own links, but our partner networks links. So Internet 2, ESNet are all connecting up all the sites in the US, and we connect to them from the European side. And also Nordinet and one of our European, or a couple of our European NRENs such as Surf, and just connect out elsewhere. But we all work together in a collaborative way in order to try and share the data globally between everyone. We're also building a submarine cable from Lisbon down to Brazil. So that should provide about, when it turns on, 200 gig of capacity direct, so it doesn't have to go via America, and it will reduce the round trip time significantly. So it's only 89 milliseconds to reach Europe from Latin America, rather than the hundreds of milliseconds it currently does. And this is important for when we're moving data from the likes of the telescopes in Chile to Europe in order for the data to be processed, and that's with the European Southern Observatory. So yeah, in terms of traffic trends, it's going up and keeps going up every year, but we're okay. The way we design our network is not like a commercial provider. So we make sure that everyone has sufficient capacity so you can burst as much data as you want. We always make sure when it reaches about 60% of usage, we double the capacity. So yeah, it's moving lots of data on the backbone is not going to be an issue. Please do it more because it's great. Just an example of one of the like a comparison between the commercial provider and the research networks is this. So we tried to move data from Geneva to Canberra to show I think it was something like 100 terabytes of data. There we go, 100 terabytes of data. The commercial networks thought it was a DDoS attack, so they stopped it. And really, you only got, in some cases, about 2 gigabit per second throughput. One of them just had next to no throughput whatsoever. But when using the research networks, if you paid for a 10 gig link, you get more or less 10 gig of data transfer speeds. So it's super quick. And yeah, not a problem to move that data around the world. We're not just doing network connectivity though, we do other specialist services. We're involved heavily in trust and identity. So if you ever use EduRoam, we're the people who help support EduRoam, and my boss, Klaas Verengen, I probably mispronounced his name terribly there, but he invented EduRoam, or was one of the inventors of EduRoam. And from that, we came up with other services like EduGain, which is your single sign-on service. Here's like an overview of some of the stuff that we do. So yeah, we do lots of different types of trust and identity, security services, as well as the network. And yeah, if you do have any problems with moving large bits of data around the world, please get in touch. We are here to help because that's what we're here for. And that's me. Thank you. Oh, you're muted, Guido.
And they let people like me drive digital infrastructures. It is a shame. All right, that is the am I frozen? No, not frozen. Good. That is the end of the more or less formal part of this presentation. This brings us to, and I will bring the slides up just funny that. Where's my screen share? Ah, here, right, yes. Just so we have a few dot points that we need to talk about now. Just a moment. There we are. Faster. Gosh darn. There we are. So it's over to the audience. Are these worthwhile topics? Do they gel with what you're doing at the moment? Does this gel with why you come to RDA? Do you represent an existing working group, or did you have ideas around your own BoF that would benefit from cross-linking with what we're doing here? Whoever wants to grab the microphone, now is your time. And if you don't, then the obvious conclusion is we will simply continue doing what we're doing, and we will use public funding and private funding to build out these infrastructures. And we think that we have the right requirements. I'll be honest that as an infrastructure provider, we are somewhat limited by the fact that in our circles, we really only ever engage with other infrastructure providers and really large science experiments. Soon the LHC, SKA, the biggest type of bioinformatics, which is why Justin is here. Climate science has recently, as of CMIP 4, come to the sort of size where we see them as a blip on our radar. But we've traditionally, I'm again speaking as an infrastructure provider, we've come to RDA trying to find places where we can engage with people who have sufficient control and visibility of their data challenges that we can start meaningfully engaging. but perhaps we're talking up the wrong tree. So if you want to steer us, now is your chance. Or leave comments in the document. Should I be looking at the document at this time?
Hi, can you hear me? I would like to
Yes.
comment.
Hey, Leandro.
Hi, how are you?
I'm good, thanks.
Well,
How are you?
Fine. Well, I was watching the presentations and I was thinking that as I'm from Iran and I participate in some events from Jean, some task forces or PRP, Pacific Research Platform, I'm a bit familiar with this, or at least I heard about some of these tools and projects that were presented. But I was thinking that to engage with RDA, we may need to, be more, let's say, less technical, or I don't know. I believe the researchers in RDA, they're not that familiar with these technicalities. You know, we need to be more like a one-on-one to them to explain more. That's my impression.
Yep.
Because I thought I find this session too technical, and you need too much background to understand. I mean,
Probably,
for
yes.
someone from RDA arriving here the first time, will be lost.
That could be true. And again, the floor is open for people who are more familiar with the goings on at RDA to tell us so. But there simply is the observation that, you know, from the people who have built infrastructures going up into the abstraction layer, and the people who think in terms of research outcomes at RDA, figuring out that you have to go somewhat down to articulate that you can't lean back and hope that the world will provide service to you, that you have to take ownership to some degree. We're going to have to meet in the middle, I think. Where that middle is, maybe we need to be dragged up further. But I simply know that talking to other infrastructure providers, this is roughly the highest point at abstraction that we are at currently. As time progresses, I'm sure that we will end up going further up. But at the same time, now it seems is the time in terms of the data volumes that a lot of research is gaining, in terms of the readiness, the consolidation that's happening towards a smaller number of more patronized technology engine rooms. Now is the iron's hot now. So if anybody wants to really benefit from this point in time, now is the time. But you're right. I mean, there is an onus on us to speak in higher abstractions. At the same time, I'm hoping, and this may be vain, I'm hoping that inside of RDA, there'll be a small contingent of people ready to delve down a bit further and find these infrastructure providers. I'm sort of like a dating show, I guess.
Yeah.
I might like to leave a few comments, actually.
Please,
my name
thank
is
you.
Oya Beyan. I am with RDA for many years now. Specifically, I am working with Fair Data. I'm part of the Fair Data Working Group. Also, I'm part of the European Open Science Cloud Fair Data Working Group. So the reason that's why I am here, actually, when we talk about making this data fair, we often don't think in terms of volume. Like I always have a feeling that we are undermining the power of this big data, how to transfer it, how to establish this cloud infrastructures. And without having that kind of infrastructure support, like just creating some metadata around data won't solve our data reusability problems. So the reasons I'm here that maybe try to bridge that two different worlds, like when we specifically I'm coming from the life sciences domain and create some metadata, describe, give the persistent identifiers, but how we can translate that FAIR principles into this cloud infrastructures. When we are moving data, how we can ensure the trust, how we can create some common policies, not maybe exactly the FAIR principles, what could be those common grounds that each cloud provider can agree on, then researchers can easily transfer their data and work with their data. So that's the reason I'm here today. I think it's kind of really nice angle to look from these two different worlds and try to find what will be the beneficial policies or let's say maybe minimum commons for researchers when we are building these data spaces.
Yeah, thank you. That is fabulous to hear. That is in fact one of the points that I was hoping to bring across, and that you've just articulated in better language. It's when you're that far down the track of readiness with your verification and metadata, etc., that you're almost ready to use these underlying infrastructures that we're trying to build as a postal service, right? You just tag your data with where you want it to move, and you're ready with that, right? You have those metadata, and we agree on what you're trying to tell us. We can actually pick it up and be your postal service. It could work like that, but we need to mull this through. But thank you very much. And if you have suggestions as to what working groups we should be talking to, I'd love to hear that. I believe Lars is raising his hand.
Yes, so a point to this, right, and very much to what I was saying before, right, is that we from the provider side have in the past worked with some very, very large science groups, right? Some of those have been mentioned here, the LHC, the SKA, and guys like that. And the thing about them is they have the capacity and the resources, the budgets to not only get the data in order, have the metadata, do all that work, but also hire the engineers to build all the tools and have the technical prowess to engage with engineers like Guido and me, right? But we believe that there are two movements, right? One is that RDA has been moving towards having a much, much better understanding of organizing of data and what data is there and how it's used by applications. And from the other end, the tools that have been developed initially for, the really big research projects like LHC have reached a level where it's possible to generalize them, where it's possible to take tools like, Ruscio was mentioned, where use it not just for something enormous like Atlas, but create instances of these tools that are approachable and usable by smaller projects who may not have time to hire a team of engineers to use it. And it would seem that there is an opportunity to use what RDA has been working at for some years and what we have been working at for some years and make it meet somewhere so we can build the appropriate tools that will allow us to make it not as simple as using Microsoft Word, right? But reasonably simple at the application level to set up an infrastructure that will move your data around as you need it in the various different instances that we heard about from OSG, for example. If you need to move data from A to B, here's tools, simple tools that can do it. If you need to integrate data movement in your workflows, here's the tools that can do it. And I think the reason we come to RDA is that we want to know what is it we need to do to help you, right? Because we believe we have tools that are powerful, but that right now are built so that you need an army of engineers to use them. And what is it we need to do to make them useful for you? So that's really, I think, the question here.
Very much so, yeah. And it's not us trying to force you on a Procrustean bed and chop off all of your actual requirements. No, the point is that we think we're ready to deal with slightly more hairy use cases, provided that they have figured out how to do metadata. So RDA seems like a natural place to do this. So, oh yeah, did you have any particular recommendations as to where we should engage further? Are there particular sort of groups of capability in NAUS?
Like RDA Fair Data Working Group will be one of the right addresses. Like I just wrote the chat, Edith Herzog is leading that group and think she might be the right contact, one of the points.
I know Edith. So yeah, that's definitely a good shout. We can get in touch with Edith.
I think David, you came off mute. David Elbert, did you want to comment?
Yeah, so thank you, Karina. A lot of things said resonate. I think one thing I find a lot in RDA, I come from material sciences, and a a lot of people don't control their stack, or at least large portions of their stack, and they need to find ways to make things happen. And I think a common thread tends to be when things are successful, they give people flexibility to connect things that they have provided to them, either through their funders or through the university or company they work in or whatever it is, with other things. So like the discussion about Globus versus Ruscio versus moving in other directions, I think it's really valuable not to try to present infrastructure to people and say this can solve your problem, as much as to say we can help you connect your infrastructure with these other infrastructures people are using to solve your problem. Ultimately, a lot of what people do when they're working with big data is they need to aggregate things, right, from different places, different sources. And so there is always some aspect. I mean, I'm a big bring the compute to the data guy, and we have infrastructure to do that. I put something in the chat about it, but there's always data somewhere else too, right? So you need to do some of each. And I think a group that brings together those different pieces and helps them link up is really a useful place to be. My 2 cents.
Yeah, no, that's a good point. The reason why I have a tendency to mention the existence of particular infrastructures anyway is, and this is really not meant to sound jaded or certainly not arrogant, but as Oya pointed out, that in groups that talk about, that focus on metadata description, there seem to be a few tacit assumptions around where that data actually lives and what it looks like. And the assumption seems to be that the data is relatively small, or at least the size of the data isn't really a problem. And it tends to live on a domain repository in the mind's eye. In the mind's eye. So there isn't an infrastructure operator underneath that repository. And yet, when you move data to the petabyte, certainly the exabyte range, there is going to be an operator. You need career paths to run these sorts of things. It's no longer 3 disks under your desk with I'll use Fedora as an example, but a particular repository implementation on it. That is just, it's not going to be like that. That's how you may grow. But by the time you become so big that you're relevant, so that is why I tend to point out that there are, if you are still able to do this at a bespoke level, fantastic and good for you. But if you find that you are going to need to partner up, then the people you're going to partner up with will tell you a few prescriptive things, not because they like to, not because that's, but because there really are, there's really only a number of choices. The era where there were a lot of different, 1,000 flowers shall bloom, it seems to be over. But that's the point I'm making, not to be,
yeah, and that's, I think I agree with that. I think in RDA, you will find lots of people though, who the idea of big data resonates, that they are there in RDA because they want to go past, or they're from communities that have gone well past that. The astronomy community is well represented in RDA and others, certainly. So I think they get that they don't always have, they don't always themselves have big projects that can then make the other steps to get to you. So finding ways to connect to them. And an awful lot of what happens successfully in RDA is sort of volunteer by hook or by crook, but it's getting the right people in the room. So they say, hey, yeah, I'll spend some time doing that with you because this is going to be fun and we're going to get somewhere.
Yeah, precisely. And look, we do realize too that those science disciplines that will knock down our door, we've already catered for them. Yeah. The onus is now on us to find those who may not completely know about what's possible, and let's not use the word corral, but figure out a way to collectivize these problems and not wait until it's too late, because then I prefer to step in when I can still delight my potential users rather than bail them out of a horrible situation. So that's what I guess I'm looking for, and I hope I'm speaking on behalf of other operators as well. But yeah, thank you. That is.
And at a normal RDA, you would find that all over the place. At every poster session and coffee, you would be talking to people who would be interested in this BoF and would have shown up and would have said, oh, well, how does that fit? I mean, that's
Yeah.
We don't have quite that level of networking through the Zoom window.
True. Initially, this BoF initially went up for the Melbourne RDA, and we callously decided, you know what, we'll wait for the next face-to-face one.
Good decision.
Yeah. Naivete. Oops. Didn't quite realize how grave this was going to be. So here we are doing it anyway. We'll probably run another one as soon as this is live again. But for the moment, this is probably just the best we can do. Did anybody see the tweets we sent out, by the way?
What's the tag on it?
We were,
RDA plenary?
No, it was chunky data. Sorry, we were being facetious.
It's all right.
Probably should have used
is big data pants. You know, you got to pull on your big data pants every now and then. So that's it can be a little tricky every time.
If anybody thought us infrastructure providers were stern people, straight-laced, then that idea is now wholly dismissed. Neil, you have your hand up.
Yeah, just picking up. I'll put video on. Hang on, you can see me. Hello, can you see me? Right. I was actually picking up when you mentioned Fedora, because one of the interesting uses for Fedora that has actually been around in a small way for a long time is its use as a metadata catalog as a metadata catalog, a metadata management system, but not actually storing the objects itself. And it's one of the issues we see with a lot of the infrastructures is actually discovery of material. And the metadata handling by a lot of the infrastructures is not terribly strong. And that's something Fedora or something like it, ambivalent about Fedora in its current guise, but anyway, but something that can actually aggregate metadata from a number of different infrastructures and say, if you're interested in this sort of data, you can find it here, here, and here. And Fedora actually provides you with a discovery layer, but doesn't actually provide you with the transport. You know, other systems are possible, you know, working with Invenio and things like that. And that's rating very much into the reuse, in that I see a lot of the discussions really are effectively the first use of the data in a lot of cases, so that all the parties there are actually aware of its existence and go there. And you're not working so much on the reuse or serendipitous discovery, or, as somebody pointed out, the aggregation of multiple data sets, possibly from multiple sources. So I see that's something that's, you know, a weakness all over the place, not just here, is actually getting that discovery. The fact that metadata schemas, there are so many of them and they're so divergent in the way they do, can make a lot of this stuff very difficult. And I think that's one of the things that's sort of chasing around several working groups within RDA, and is certainly a place where sort of, I come from effectively a library background, actually finding things is part of my bread and butter, is where there's actually some useful work to be done.
Yes, quite. And I was digging around in my brain for an example of a repository implementation, and shouldn't have used Fedora, but it was the only one that came up. I probably should have said Dryad or something. But yes, you're right, because of the metadata aggregation actually already exists. And sometimes a useful way to get cracking about this is simply to get started with a simple use case and see what you end up ironing out without trying to boil the ocean. Just you pick one, you see how well Fedora and its metadata aggregation holds up when you connect it to a backend data movement infrastructure, and then socialize those results, whether good or bad. Good, ideally, but bad is a learning experience as well. You then engage with the coders or the people who hold the use case, etc. Would there be, you seemingly being quite an expert in these matters, would there be a working group that we should be engaging with? Is there a particular use case that would be beneficial if we picked it up right now and use that to build a proof of concept around that we could then socialize at the next RDA? Or
I would say it is the nature of RDA. There are probably several groups. There is a repositories group. There are several metadata groups as well. And so, yes, you can take your pick really as to which direction you go in. You know, not here, but I can dig up several cases. I mean, we do this in Oxford. We have something called Aura Data, which is our data repository, but it accepts basically catalog entries as well. So if your data is already sat in an infrastructure, we will just take a record and say, we know it exists. We will hold a record for the purposes of discovery and dissemination, and we will point you as to how to get that. But we won't actually hold the data itself. So we do that in a little way there. But it's starting, a lot of that I think is about the protocols, which says it would be nice to, you know, you'll have things like OAI PMH to harvest metadata, to be able to go around and say, okay, I'm interested in this particular type of data. Can I go around and have a look at the infrastructures and pull the metadata down and say, what have you got that matches this profile? Now, to some extent, you can do that, but at the moment, there's not enough alignment of the metadata for those searches to work very well. And you tend to be dropping back to something more or less like Google, which is a bit generic. So
doesn't quite have the governance control that we're looking for.
For coming together there.
Yeah.
Yeah. But,
no, but I'm here to take guidance, because you know this landscape much better than we do, and even to you, it appears that there are lots of ways to skin this particular cat.
That's right.
And in all honesty, us infrastructure providers are essentially, we're technology yokels, right? We take a copper hammer to everything, and then we try to fix it. If there is a pick between two groups, and one of them is very scholarly and the other one are a bunch of plumbers, point us towards the plumbers.
Yeah. So I would say, yeah, I mean, there is repositories group. I'll dig up the link anyway, and find that within RDA, which will be worth looking at. Some of those, certainly from the technical point of view, those are where you'll meet the Fedoras, the Dryads, and the other thing.
Yep. Links, names, help, use cases,
that's
particular,
right.
If you have them. Sorry to lean on you, but.
Yeah, that's right. Well, I'll stick some things in the document, because I'll have to go.
Thank you very much, Lee.
Yeah. Some links in there,
yeah.
But certainly, you know, I guess it's not my primary concern, but it is something that we're seeing is a lot of this in terms of reusability. You kind of hit on reproducibility. You know, if software is easy to port and move into the cloud and easy to spin up an instance for, then it's easy to move it towards the data, but it's also easy for somebody else to reproduce. If it's hard to do that, then there are issues related to reproducibility of that as well, if it's hard to actually spin up an instance of that code. So there are little sort of relationships between how we approach things and whether they may be knock-on effects and other things interfere. But yeah, I'll put some things into the document in terms of the working groups and other things that you can look at, and everybody else can see those rather than reel them off right now.
Thank you very much. We're closing towards where we should be. Signing off and allowing you to roam free again. I'm sure this time zone is awkward for some of you, but I'll pass the microphone around one more time, virtually. But if there are no further questions, then I'd like to thank all of you for your attention and your attendance and your pitching in and your lively contributions. And those of you who have listed their names and email addresses, we will be circulating minutes and future actions in a couple of weeks' time, I think. Thank you all for joining, and I hope you have an excellent remainder of this RDA virtual.